Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll introduce you to Amazon's Simple Notification Service, or SNS, a fully managed messaging service designed to enable decoupled and event-driven architectures. We'll explore how SNS works, its core components, and the typical use cases where it excels, from fan-out messaging to mobile push notifications and application-to-application communication. Let's get started. In today's cloud-native architectures, the need for systems that are loosely coupled, scalable, and responsive is more critical than ever. This is where the publish-subscribe model, or pub/sub, comes into play. At its core, pub/sub enables asynchronous communication between components. Publishers emit messages to a topic without needing to know who, if anyone, is listening. Subscribers, on the other hand, express interest in those messages and receive them independently. This decoupling is a game changer. It allows each part of your system to evolve independently, deployments become safer, and changes in one service don't break another. And when it comes to scale, pub/sub shines. A single message can fan out to dozens or even hundreds of subscribers in parallel, enabling high-throughput, distributed processing that's ideal for microservices, data pipelines, and event-driven workflows. Real-time responsiveness is another key benefit. Whether you're sending alerts, processing transactions, or delivering push notifications, pub/sub models allow data to flow instantly from producer to consumer. And the model supports diverse subscriber types, whether it's AWS Lambda for serverless execution, SQS for guaranteed delivery, or HTTP endpoints for custom applications. This model also boosts system resilience. If a subscriber goes down, the publisher doesn't need to know. Messages can be retried, routed to a dead letter queue, or processed later, keeping the system robust in the face of failures. Plus, adding new subscribers doesn't require touching the publisher at all. Just register and go. Amazon's Simple Notification Service, or SNS, is a fully managed publish-subscribe messaging service that allows you to decouple microservices, distribute messages at scale, and build event-driven architectures without managing messaging infrastructure. With SNS, you can publish messages to a central topic and have those messages instantly delivered to multiple subscribers across a variety of protocols. SNS supports multiple delivery targets out of the box, including Amazon SQS queues, AWS Lambda functions, HTTP or HTTPS endpoints, as well as email, SMS, and mobile push notifications. This makes it incredibly versatile, capable of handling both internal application messaging and external user engagement. One of its key strengths is its ability to fan out messages. When you publish to an SNS topic, that single message can be replicated and delivered in parallel to all subscribed endpoints, enabling efficient and scalable communication across distributed systems. Performance is another major advantage. SNS is designed for high throughput and low latency message delivery. Whether you're processing millions of events per hour or sending critical alerts in near real time, SNS delivers reliably and quickly. It also offers built-in support for retries and dead letter queues, especially when integrated with SQS, helping you build fault-tolerant systems that handle failures gracefully. With message filtering, you can add subscribers to a single topic, but control which messages they receive using attributes, reducing noise and improving efficiency. And best of all, SNS fits naturally into the broader AWS ecosystem. It integrates seamlessly with CloudWatch for monitoring, CloudFormation for infrastructure as code, Lambda for event processing, and EventBridge for advanced event routing. Let's take a closer look at the core building blocks of Amazon SNS. These are the foundational elements that enable its flexibility, scalability, and simplicity. At the heart of SNS is the topic, a logical communication channel that serves as the central hub for message delivery. When a publisher sends a message, it targets a topic. This design makes it easy to fan out messages to many subscribers simultaneously. Publishers are the services or applications that generate messages and push them to an SNS topic. They are completely unaware of who will receive the message, allowing the system to remain loosely coupled. This decoupling is crucial for scalable and maintainable architecture. Subscribers are the endpoints that want to receive messages from a topic. These could be other AWS services like SQS or Lambda, or external services via HTTP or HTTPS. SNS also supports messaging directly to people through email, SMS, or mobile push notifications. The link between a topic and a subscriber is known as a subscription. Each subscription defines the endpoint and the protocol used for message delivery. One topic can have multiple subscriptions, even across different protocols, making SNS incredibly flexible. Another powerful feature is message filtering. This allows subscribers to specify which messages they want to receive based on attributes in the message payload. It's a great way to reduce noise and route messages intelligently to the right consumers without creating multiple topics. Finally, SNS supports multiple delivery protocols, enabling seamless integration across diverse systems and platforms. Whether you need to trigger a Lambda, push to a queue, or send a mobile alert, SNS has you covered. Publishing to Amazon SNS is a straightforward but powerful process that allows applications to send messages to one or more subscribers through a central topic. There are several ways to publish messages, using the AWS Management Console for manual publishing, or programmatically through the AWS CLI, SDKs, or the Publish API. These programmatic options are especially useful for integrating SNS into automated workflows and application logic. Every SNS topic has a unique identifier called the topic ARN, or Amazon Resource Name. When you publish a message, you specify this ARN so that SNS knows exactly where to route the message. The message payload itself is typically a simple string, but SNS also supports structured payloads, such as JSON. This is particularly useful when you're sending messages to different types of subscribers. For example, one message might go to an SQS queue, another to a Lambda function, and a third to a mobile device. To support these diverse delivery protocols, SNS offers protocol-specific formatting. You can customize the message content for each endpoint type within a single publish operation. That means the same message can look different to an email subscriber versus an HTTP endpoint, ensuring appropriate formatting for each target. Another valuable feature is message attributes. These are optional metadata key value pairs that accompany your message. They're especially useful when you're using message filtering. Subscribers can choose to receive only messages that meet certain criteria, such as a specific event type or source application. SNS also handles retries automatically in case of temporary failures, ensuring better reliability. For FIFO, first in first out topics, you can use message deduplication ID to avoid publishing duplicate messages, adding another layer of control and consistency to your messaging workflows. Amazon SNS FIFO topics, short for first in, first out, are designed for use cases where the exact order of message delivery and exactly once processing are critical. Unlike standard SNS topics that offer best effort ordering and at least once delivery, FIFO topics are built to maintain strict ordering guarantees and eliminate duplicates. Each message published to a FIFO topic must include a message group ID. This ID allows SNS to isolate ordered message streams within a topic. Messages that share the same message group ID are always delivered in the exact order they were published. Perfect for scenarios like processing financial transactions, stock trades, or changes to a shared resource where sequence matters. FIFO topics also support exactly once message delivery, thanks to the use of message deduplication ID. This identifier can be set manually by the publisher or generated automatically based on the message body. If a duplicate message is detected within a 5-minute window, SNS discards it, ensuring that downstream systems don't process the same message more than once. Currently, FIFO topics support only Amazon SQS FIFO queues as subscribers. That means you can't use FIFO topics to push messages directly to Lambda functions, HTTP endpoints, or email like you can with standard topics. This trade-off exists because the FIFO model is tightly coupled with queue-based processing semantics. There are also naming rules. FIFO topics must have names ending with .fifo, making them easily distinguishable from their standard counterparts. It's important to note that FIFO topics have lower throughput limits than standard topics. They're designed to prioritize delivery guarantees over raw speed. So while they're not suited for high-velocity broadcast patterns, they're the go-to choice when order and precision are paramount. Managing subscriptions in Amazon SNS is central to controlling how messages flow from your topics to your subscribers. At a basic level, a subscription defines how and where messages from a topic are delivered. When creating a subscription, you specify three key things: the topic ARN, the communication protocol such as SQS, Lambda, HTTPS, email, or SMS, and the destination endpoint. A single topic can support multiple subscriptions, even across different protocols, allowing for powerful fan-out patterns. For some protocols, like email or HTTPS, there's a confirmation workflow involved. After you create the subscription, SNS sends a confirmation message to the endpoint. The subscriber must explicitly confirm the subscription before any messages are delivered. This ensures that the endpoint owner consents to receive messages and helps avoid misconfigured or malicious integrations. One of the more powerful features of SNS subscriptions is message filtering. Using message attributes, you can define filtering policies so that a subscriber only receives messages relevant to its use case. For example, a subscriber can filter on a message attribute like event type or region to receive only a targeted subset of all published messages. This reduces overhead and makes your architecture more efficient and event-aware without requiring you to create multiple topics. SNS also offers a raw message delivery option. This is especially useful when working with Amazon SQS or HTTP endpoints. By default, SNS wraps the message in a JSON envelope, but with raw message delivery enabled, the subscriber gets the exact message body without any additional metadata. This is handy for legacy systems or services that expect a simpler, unwrapped format. Finally, you can manage subscriptions through the AWS Management Console, AWS CLI, or any of the AWS SDKs. This gives you flexibility to automate subscription management in code or make quick updates via the web interface. Whether you're scaling your architecture or experimenting with new endpoints, SNS makes it easy to manage subscriptions at any scale. One of the most powerful features in Amazon SNS is message filtering, which gives you precise control over what messages are delivered to which subscribers, all without the need to create and manage multiple topics. Filtering in SNS is attribute-based, meaning that when you publish a message, you can attach metadata as key value pairs, called message attributes. These attributes describe properties of the message, like event type, severity, or region. Each subscription to a topic can have its own filter policy, which tells SNS what kind of messages that subscriber is interested in. For example, one subscriber may only want to receive messages where the region attribute is set to US East 1, while another only wants event type set to order placed. SNS evaluates these policies at the time of publish, delivering each message only to the subscribers whose filters match. SNS filter policies support a range of data types and conditions. You can match exact strings, numbers, booleans, and even use advanced conditions like prefix, anything but, and numeric ranges. This lets you craft expressive and granular filtering logic without any downstream filtering code. Importantly, SNS supports logical and or semantics within filter policies. You can combine multiple attributes in a single policy to ensure that only highly specific messages are delivered. For example, you could set a policy to receive messages only when event type is alert and severity is high. There's one key behavior to remember. If a message doesn't include the attributes required by a subscription's filter policy, that message is not delivered to the subscriber. This protects endpoints from receiving irrelevant data and reduces unnecessary processing. Let's explore how Amazon SNS topic filtering streamlines communication in a modern e-commerce architecture. The journey begins when a customer places an order through the online storefront. The ordering service captures all relevant order details, including the current state of the order, the items purchased, and the total cost, and immediately publishes this event to Amazon SNS, the simple notification service. This event is broadcast to multiple SNS topics that represent different facets of the order lifecycle: one for orders, one for fulfillment, and one for payments. Each topic serves as a dedicated channel for downstream systems to consume order-related updates. Now, this is where SNS topic filtering becomes powerful. Every subscriber to a topic, such as Amazon SQS queues, Lambda functions, or email services, can define filter policies to receive only the messages that are relevant to their purpose. For instance, let's say an SQS queue is interested only in confirmed orders. It subscribes to the order topic with a filter policy for state confirmed. As a result, it will receive only those messages where the order state is confirmed. In contrast, if an order is canceled, an SQS queue handling refunds and an email notification service subscribe to cancellation alerts, both using a state canceled filter, will be triggered. Similarly, when the order reaches the shipped state, the shipping topic notifies a logistics queue and a customer-facing email service. Again, but only if the filter policy matches state shipped. This intelligent filtering mechanism ensures that each subscriber only receives what they need. No more, no less. It reduces message clutter, lowers processing overhead, and makes the system more responsive and cost-efficient. One of the most powerful architectural patterns enabled by Amazon SNS is fan-out, the ability to take a single published message and deliver it to multiple subscribers simultaneously. When paired with Amazon SQS, this pattern becomes a foundation for building decoupled, scalable, and fault-tolerant systems. At its core, fan-out means that a single SNS topic can have multiple SQS queues subscribed to it. When a message is published to the topic, SNS delivers a copy of that message to each queue, allowing multiple downstream systems to consume and process the same event independently. This design decouples producers from consumers. Producers don't need to know who the subscribers are or how they're processing the data. This model also promotes parallelism and scalability. For example, one queue could trigger a billing system, another could initiate an email notification, and a third could log the event for analytics. Each consumer runs at its own pace, and each SQS queue acts as a buffer that helps smooth out load spikes and isolate failures. SNS supports delivering messages to both standard and FIFO SQS queues, so you can tailor delivery guarantees to the use case, using high throughput at least once delivery with standard queues, or exactly once ordered delivery with FIFO queues. Another key advantage is message filtering. Each SQS subscription to an SNS topic can include a filter policy so that only relevant messages are delivered to that queue. This means you don't have to write custom logic in each consumer to sort through events. It's handled right at the messaging layer. Finally, this architecture enhances error isolation. If one downstream service fails or slows down, the other consumers are unaffected. Each queue can be scaled independently, giving you a flexible and resilient event-driven backbone for your applications. When building applications that rely on Amazon SNS for critical messaging, security and compliance are paramount. AWS provides robust features to ensure that your SNS topics and messages are protected from unauthorized access, data leaks, and compliance violations. SNS ensures end-to-end data protection. Messages are encrypted at rest using AWS managed or customer managed KMS keys and encrypted in transit using TLS. This prevents unauthorized access to your messages, whether they're stored on disk or moving through the network. One of the first layers of defense is IAM-based access control. With IAM, you can define who has permission to publish messages to an SNS topic, who can subscribe, and who can manage the topic itself. In addition to IAM, SNS supports resource-based topic policies, which are especially useful in cross-account scenarios. SNS supports message signing and validation, especially for HTTPS endpoints, ensuring that messages have not been altered in transit and truly originate from AWS. For environments with strict networking requirements, SNS integrates with AWS Private Link, allowing secure communication between your VPC and SNS over private endpoints. This means your messages never traverse the public internet, improving both security posture and compliance with data residency rules. Finally, to support auditing and compliance tracking, SNS is fully integrated with AWS CloudTrail. Every API call, whether it's creating a topic, subscribing a service, or publishing a message, is logged and available for review. With built-in support for major compliance programs like HIPAA, GDPR, SOC, and ISO, SNS is ready to meet the needs of regulated industries, offering both operational peace of mind and architectural flexibility. When considering Amazon SNS as your messaging backbone, it's important to understand its flexible and usage-based pricing model, which allows you to scale affordably while only paying for what you use. First, Amazon SNS offers a generous free tier. You get 1 million SNS requests per month at no cost. This includes publishes, deliveries, subscription confirmations, and other API actions. It's ideal for development environments, prototypes, and even light production workloads. Beyond the free tier, SNS pricing is primarily based on request volume. Each publish action, each message delivery attempt, and each subscription confirmation is considered a request. Charges scale linearly with usage, giving you cost transparency as your system grows. Delivery pricing also depends on the protocol used. For example, delivering to SQS or Lambda has a different per request cost than delivering to HTTPS endpoints or mobile push notifications. SMS delivery, in particular, is priced differently. Costs vary based on the destination country, message length, or segments, and carrier-specific surcharges. International SMS delivery is typically more expensive than domestic. If you're using FIFO topics, expect higher pricing compared to standard topics. This is because SNS has to guarantee strict message ordering and deduplication, which introduces more operational overhead. Keep in mind that data transfer charges apply when messages are sent across AWS regions or to endpoints outside of AWS. While these costs are often minor, they can add up in high-volume, cross-regional setups. Finally, you can optimize your SNS spending through message filtering and downstream batching. By sending messages only to relevant subscribers and by processing them efficiently in services like SQS or Lambda, you reduce unnecessary traffic and gain cost efficiency. Monitoring is a crucial part of operating any distributed system, and Amazon SNS provides a rich set of tools to help you observe, analyze, and respond to your messaging workflows in real time. At the heart of SNS monitoring is its integration with Amazon CloudWatch. SNS automatically publishes operational metrics like number of messages published, number of notifications delivered, and number of notifications failed. These metrics provide immediate insight into how your topics are performing and how reliably your messages are being delivered. Using CloudWatch alarms, you can create threshold-based alerts for these metrics. For instance, you might set an alarm if delivery failures exceed a certain count within a minute. For more granular insight, SNS supports delivery status logging. This allows you to track whether each individual message was successfully delivered or not. Across supported protocols like HTTPS, Lambda, email, SMS, and SQS. SNS also supports dead letter queues or DLQs, which are especially useful when messages can't be delivered after multiple retries. These failed messages are routed to an SQS queue where they can be inspected and replayed manually, ensuring you never lose critical data. When SNS is integrated with AWS Lambda, you can take advantage of AWS X-Ray to trace the complete journey of a message, from the SNS topic through Lambda invocation and any downstream dependencies, giving you end-to-end visibility into system behavior and latency. To manage and monitor large-scale SNS usage across environments, you can use resource tagging. This allows you to build organized, filterable CloudWatch dashboards based on teams, applications, or environments. Finally, for teams using centralized monitoring platforms, SNS metrics and logs can be exported to third-party tools like Datadog, Splunk, or Prometheus using AWS integrations, enabling unified observability alongside other services. Choosing the right messaging service depends heavily on your use case, architectural goals, and operational preferences. Let's compare Amazon SNS with a few prominent alternatives: Amazon SQS, Amazon EventBridge, and Apache Kafka across key dimensions. Amazon SNS uses a push-based pub/sub model designed for instant fan-out to multiple subscribers. It excels in scenarios where you need near real-time notifications sent to diverse endpoints such as HTTPS, AWS Lambda, SQS, or even SMS and mobile devices. Amazon SQS, on the other hand, is a pull-based queuing system. It decouples producers and consumers, allowing consumers to pull for messages at their own pace. This makes it ideal for decoupled, fault-tolerant workflows where guaranteed processing is more important than instant delivery. Amazon EventBridge is positioned as an event bus for AWS service events and custom application events. While it shares similarities with SNS in terms of routing, EventBridge is better suited for complex filtering, event transformation, and third-party SaaS integrations. It excels in orchestrating event-driven architectures with rich semantic routing. When compared to Apache Kafka, SNS stands out for its fully managed simplicity. Kafka, while extremely powerful, demands significant operational overhead, including provisioning, managing brokers, handling partitions, and scaling consumers. Kafka's strength lies in stream processing and high-throughput ingestion, making it ideal for analytics pipelines and large-scale data streaming. SNS, however, is optimized for simpler pub/sub use cases, rapid fan-out, and low-latency delivery. From a feature standpoint, SNS now offers FIFO topics that provide message ordering and deduplication, bringing it closer to Kafka in terms of reliability for ordered message delivery, without the complexity of managing infrastructure. Ultimately, Amazon SNS offers a lightweight, versatile, and highly scalable option for event distribution, especially when paired with other AWS services. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.